My name is Ms. Levin. I am here to explain a few things about what we are currently learning in Unit 2 in your child's class every day. So the first thing that I want to start with, first I want to say that a lot of people had questions about the homework this week, and I would like to help you with that. However, before I can help you with that, I would like to explain to you a few of the I can statements and what that means for your child. So your child should know these things already before starting the homework this week, okay? So the first I can statement here is I can express powers of 10 using exponents. So in your child's math notebook, they should have a chart, okay? And the chart that we wrote down last week began with 10 to the 0 power, 10 to the first power, 10 to the second power, 10 to the third power, 10 to the fourth power, 10 to the fifth power, and I believe we stopped at 10 to the sixth power in class, but on the anchor chart in class, I actually go out to 10 to the seventh power, and I'm going to show you why here in a minute, okay? So we learned that you just have to remember that anything to the 0 power is 1. There's no explanation that we can give at a 5th grade level to explain this. You just have to know. Just like you remember, anything you multiply by 0 is 0. Anything you multiply by 1 is itself. And here, anything to the 0 power, 10, 3, 7, 12 to the 0 power are all 1. Okay? If you ever see anything to the 0 power, it is 1. Just remember it. Okay? 10 to the first power means that I have 10. Just 10 by itself. Okay? 10 to the second power tells me that I have 10 times 10. I have 10 multiplied 2 times. A 10 here and a 10 there. Okay? So 10 times 10. For 10 to the third power, I have 10 times 10 times 10. Okay? And that is the pattern that should be recognized all the way down here. Okay? You should see it all the way down. And so I'm just going to go ahead and finish this out. I have 10 times 10 times 10 times 10 times 10. Four, five, six. Oh, and one more. 6, 7. All right. Kids are smart. They have figured this thing out, okay? What you should notice also is that 10 times 10, most of us know, is equal to 100. Okay? And the correlation that we will start to see is that whatever this exponent is, it's kind of a cheat code. It will tell us how many zeros will come after this 1 in our final product. So with that being said, 10 to the third power, or 10 times 10 times 10, is equal to 1,000. 10 to the fourth power is 10 times 10 times 10 times 10, which is a 1 followed by 4 zeros, or 10,000. 10 to the fifth power is 10 followed by 5 zeros, or 100,000. 10 to the sixth power is 1 followed by 6 zeros, or 1 million. Okay? And oh yeah, so I think I did stop at 6. I think we stopped at 1 million, so I won't actually go on any further here. Let's erase this actually. Get rid of that really quickly. Okay? So with that being said, you notice the pattern. Whatever my power is how many of those zeros follow behind 1. Okay? So that's number 1. That is showing, if your child can do that, then that means that they can express powers of 10 using exponents. The next I can statement says I can explain the pattern for the number of zeros in a product and how they relate to a power of 10. Okay, there are a couple different ways to do this. This reflects the homework from last week. So I believe we had a couple of examples last week, and I'm making this up completely off the dome. Okay, so if I have 4 times 10 to the first power, that is equal to 4 times 10. And 4 times 10, as we all know, is 40. Okay? In the same way that if I said 4 times 10 to the second power is equal to 4 times 100, we know that that is equal to 400. Okay? So I'll skip a little bit here. This continues on. If we have 4 times 10 to the fifth power, we know that that is equal to 4 times 100,000, which would be equal to 400,000. And so once again, you will start to notice the same pattern that we had up above here. And that pattern essentially shows us that whatever that power is, I take that number and I realize that this is the same number of zeros that will follow behind my number that is being multiplied. Okay? There is a pattern here. You put that 4 and then you find the number of zeros that will be following that 4. And then you place the 4 here and you have 1, 2 right here. And so now we know that 4 times 10 to the second power, you can take that 4, follow it by the number of zeros, and you get your answer. Okay? All right. Number 3, it says I can explain and represent the shift in digits when multiplying and dividing by powers of 10. Okay? So, as a disclaimer, I want to say that this is different, even from the way that I learned when I was in elementary school. When I was in 5th grade, we did not learn this way. We learned how to move the decimal, essentially, okay? And so before I talk about moving the decimal, I want to follow what the intention is behind shifting the digits when multiplying and dividing by powers of 10, okay? So, let me quickly draw a place value chart right here. Okay, so I have my chart drawn here, very makeshift, okay? But keep in mind, we are explaining and representing the shift in digits when multiplying and dividing by powers of 10, okay? So what the goal is here to understand is that when you are multiplying and dividing by digits of 10, okay? When I multiply a place value by a digit of 10, that digit will shift, okay? So, for example, if I have 2 ones, okay? If I multiply 2 times 10 to the first power, that tells me, well, first of all, my answer, of course, the way I work this out is 2 times 10 is equal to 20. So I know in my head that 2 times 10 is 20. But what is actually happening here? So I know that I have a 1. Oh, I have a 2, excuse me. I have a 2 in the ones place, which is right here, right? So what has happened? My 2 has shifted to the tens place, such that anytime I multiply a number that has a place value, anytime I multiply a number by 10 to a certain power, I am multiplying that number by 10, and it is shifting to the left. Okay? Now we all know that you can't have a place value. Let me put my decimal point here. You can't have a one's place value with no placeholder. So that placeholder then becomes a 0. Okay? Now, if I take this same 2, okay? Let's just go back. So if I take this same 2 right here, if I take this same 2 here and I multiply it by 10 to the second power, we can do the math for that. We know that that's 2 times 10 times 10, which is equal to 2 times 100, which is equal to 200, right? I'm just writing it all out so that we can all see it. I want all the dots to be connected here, okay? The shift that is taking place is that I am now, because I have this 10 to the second power, and I am multiplying it times 10 twice, I need to not only shift this one time, but I also need to shift it a second time. Okay? So that means I essentially will be multiplying, of course, times 10 twice right here. And I will go 1, 2. And we know that our placeholders have to be after this 2 here. So I put a 0 here. I put a 0 here. And that is how I get 200. Okay? And we can take it a step further, of course. And let's do 2 times 10 to the 6th power. That's equal to 2 times 10 times 10 times 10 times 10 times 10 times 10, which is equal to 2 times 1 million, which is equal to 2 million. Let's put some commas in here so we don't get confused. Okay. So once again, we did a really big one this time. So 6, 2, 3, 4, 5, 6. And so now we have our 6 zeros here. But what that means is that I'll have now taken my 2 that was in the ones place, and I have shifted not 1, not 2, but 3, 4, 5, 6 times. So I've multiplied times 10 6 times. Okay? And when I do that, my 2 is shifting 3, 4, 5, 6 times. And my placeholders would be those zeros. So my number, as we already figured out down here, is 2 million. Okay? All right. I know it's a lot. It's a little difficult. I get it. but also this is how your child is being taught this in class. They're being taught to shift the place value and not necessarily to move the decimal. Okay. So yes. Okay. Now we talked about shifting to the left. If we are shifting to the right, and let me just copy my little chart here because I kind of want to cheat a little bit in that I want to just, I want to put this back and I just want to copy. Let's copy this. Paste it. Why won't it let me grab it? Let's see. Hold on. Let's try again, guys. Oh, there we go. Okay. Beautiful. Okay. So now we are going to be shifting by dividing. Okay. So what that means is if I have a number, I'm going to use a different number this time just to switch it up a little bit. Okay. So let's say I have 300. If I have the number 300, your students should be able to place this onto the chart. I have a 0 in my ones place. I have a 0 in my tens place. I have a 3 in the hundreds place. So just like this, okay? If I divide 300 by 10, that is the same as multiplying by 1/10, okay? These things are equivalent. It's just a different way to say it. So you may know that 300 divided by 10 to the first power, right, is equal to 30. But how do we show that as a shift in place value? So your child must know that 10 to the first power is a one-time shift, okay? And since it is a one-time shift, we are dividing. And so when we divide, we are taking this value and we are moving it this time to the right. Okay? We are either dividing by 10 or multiplying by the fraction that is 1/10. Okay? In the same way, there is that one shift there, right? So if I take that same number, 300, and I divide it by 10 to the fifth power, once again, that's the same as taking 300 and multiplying it by 1 over 10 to the fifth power. So that would be equal to 300 divided by 10 times 10 times 10 times 10 times 10, or 300 multiplied by 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10. Okay? Which is equal to 300 divided by 100,000. Okay? Or 300 times 1 over 100,000. Okay? And this one isn't as easy, so maybe you don't know this off the top of your head. But what your child should recognize is that we are taking 300 with a 3 in the hundreds place, which is what I have here, and we are shifting it 5 times because that is our exponent. So 1, 2, 3, 4, 5. Okay? So I am physically taking my 3. I'm going to remove my zeros for right now. Oh, you know what? I could leave my zeros there. Let's leave. Well, no, I'm going to erase them. Okay? So I'm going to physically take my 3 and I'm going to shift it. Okay? So I'm going to go 1, 2, 3, 4, 5. Okay? So that takes my 3 from the hundreds place and puts it in the thousandths place. Okay? But also, I need these leading zeros, right? I need these place value filling zeros. So we need to make sure, one, that all of our zeros are filled up to our decimal point, and also our ones place has to have a 0 in it as well. Okay? So that means that our answer is 0.003 in both scenarios. You can show either of these ways. It does not matter to me if your child says 10 to the 5th or divided by 10 to the 5th or multiplied by 1 over 10 to the 5th. The standard wants the child to know that these two things are interchangeable. Okay, as long as they know that they mean the same thing, they only have to show work for one. Okay. And in this, we've covered just about everything here. The last two say I can identify that a digit to the left is worth 10 times more than the digit to the right. Oops, you know what, guys? I'm sorry, I forgot to write divided by 10 all the times here. Divided by 10, divided by 10, divided by 10, divided by 10. Or times 1 over 10, times 1 over 10, times 1 over 10, times 1 over 10. Okay? So once again, those are interchangeable. So from all of this is what we've been working on the last couple of weeks. Your child should be able to identify that a digit to the left is worth 10 times more than the digit to the right, right? They should be able to recognize that the digit to the left is worth 10 times more than this digit here. Let's make this a little bit smaller. All right, this digit to the left is worth 10 times more than this digit place value to the right. And they should also be able to identify that a digit to the right is worth 1/10 of the value of the digit to the left. Okay? I hope this helps. And now we can move on to the homework. That'll be in a separate video.